Hello everyone. Today we are going to start with a new chapter called Introduction to Euclid's Geometry. Myself Palak Agarwal and I'll be continuing for you with this lecture. So shall we start and see what is all in it for you today? Okay, so let's start. What is geometry? Okay, the word geometry comes from a Greek word geo meaning the earth and metron meaning to measure. So it's basically geometry appears to have originated from the word need of measuring land. Okay, since geo means earth and metron means to measure. Okay, so this branch of mathematics was studied in various forms in very ancient civilizations like Egypt, Babylonia, China, India. Okay, so the people of this civilization faced several practical problems which required development of geometry in various ways. Now, what were their problems which led to the development? Let us see. The first example in front of you was of the river Nile. Whenever it overflowed, the boundaries need to be redrawn. Okay, since different countries have their boundaries, but due to the water being flowed on them, the boundaries swept away and they need to be redrawn. So there were certain measures which were taken to measure the land. Obviously, if the boundary is not there, you can't just say or claim that this land is yours. There need to be a technique or method to fulfill the requirements of measuring the land. So here comes the need of geometry. Second, this knowledge of geometry was also used by them for computing volume of granaries and for constructing canals and pyramids. Now, if you are aware of the construction site a little bit, that requires geometry in a very specific way. Okay, even I would say the designing part, it requires geometry. Okay, now India's contribution to geometry. In Indian subcontinent, the excavations at Harappa and Mohenjo-daro, etc., show that the Indus Valley civilization made extensive use of geometry. I hope you have known from history about the Indus Valley civilization. Okay, it's a very highly organized society, and the cities were highly developed and very well planned. The architecture of India is strictly and typically shown here. Okay, so these are the examples. For example, the roads were parallel to each other. There was an underground drainage system at that time. You don't compare it to today's world. It's a lot all development going on, but at that time the geometry was in full and full demand. Okay, so the bricks used for construction were keen fired, and the ratio length, breadth, and thickness of the brick was known for them to be of successful use. Okay, in Indian Asian, so India, the Sulbhaturas were the manual of geometric construction. Okay, so they followed this Vedic period originated, and the construction of altars or Vedis, fireplaces for performing Vedic rites. So this geometrical organization which started, we can say that India has a big part in them. Okay, now the Siyant given by the Arthveda consists of 9 interwoven isosceles triangles. Okay, like you can see in the figure. Okay, the triangles are arranged like 43 subsidiary triangles. So this is what? This is the work of geometry. Now at that time nobody know what isosceles triangle are. I hope you know that. Okay, so yeah. Now, geometry behind Euclid. Now, Euclid's geometry we are going to know. So we have to start with the what was history of Euclid. So this example show that geometry was being developed and applied everywhere in the world. But this was happening in unsystematic manner because everyone was following what they have known and what they have excavated. So what is interesting about this development of geometry in the ancient period is that they were passed from one generation to another and either orally or through palm leaf messages. So, in order to develop, what does one need? The generation should know what already have been done. So, in that way, the messages were passed. We found out in some civilization like Babylonia, India, Rome, and Egypt, geometry remained a very practical oriented discipline. The geometry developed by Egyptians mainly consisted of statement of results, and there were no general rules of the process. In civilization like Greece, the emphasis was on the reasoning behind why center constructions work. Okay, so every country. Now, I'm not reading it all. I'm just giving you an idea that every country has a different practical use of geometry, and they created a different manual. Like, see here, Egyptians created the manual for statement of results. Greece has the reasoning behind why construction has to be a certain way. So everyone have a different opinion about geometry. Now, What was Euclid's geometry? A Greek mathematician, Thales is credited with giving the first known proof, and this proof was a statement that a circle is bisected, that is, cut into two equal halves into its diameter. So I know it's funny to think now, like, yeah, it's obvious circle has a diameter. But at that time, the person who invented this, which we are thinking is very simple, was Thales. So just think of a person like defining the definition of diameter, circle. One of Thales' most famous pupil was Pythagoras. Okay, so the one we use in geometry. Okay, so this was the history of Thales, how the circle definition came. At that time, Euclid, a teacher of mathematics at Alexandria in Egypt, collected all the known work and arranged it in a famous treatise called Elements. So he created a book kind of thing, or a general kind of thing, which was called Elements, and he divided everything. He wrote every known fact in that. He divided element into 13 chapters and each called a book. Okay, so every 13 part of the journals were different book, and this book influenced worldwide about the geometry. So what is Euclid's definition? Now let's see. We have seen the history of Euclid and what he is known for. Now what's its definition? A Greek mathematician of Euclid's time thought of geometry as an abstract model of the world in which they lived. The notion of point, line, plane, or surface, and so on was derived from what was seen around them. From studies of the space and solid in the space around them, an abstract geometrical noun of a solid subject was developed, and each boundaries are called surfaces. Okay, so they separate one part of space from another and are said to have no thickness. The boundaries of a surface are curves or straight lines. They depend, and these lines end in points. So points definition, line definition, surface and curves all were defined in such a simple way. Solid, 3 steps from solids to point. Solid, surface, lines and point. In each step we lose one extension, also called a dimension. So solid has 3 dimensions, surface has 2, line has 1 and point has no dimension. So we are losing the dimensions at every point. So this is what Euclid's definition. A few points of the definitions are given below. A point is that which has no part. A length is breadthless line, and our ends of a line are points. The straight line is line which lies evenly with the point on itself. A surface is that which has length and breadth only, 2 dimensional, right? And an edge of a surface are lines. A plane surface is a surface which lies evenly on a straight line with itself. Okay, so if we carefully study this definition, we'll find that some of the terms like part, breadth, length, evenly need to be further explained clearly. For example, consider this definition of a point. In this definition, a part needs to be defined. What is part? Which has no part. So what part? Suppose if we define a part to be that of which occupies area, again an area needs to be defined, right? So to define one thing, we need to define the other things. You may get a long chain of definition without a name, because everything comes from a word and every word needs to be defined. You can't just accept every definition without the discipline or without the definition being clear. Okay, so that was the problem behind the definition. However, we do have an intuitive feeling for the geometrical concept of point, what a definition gives us. Obviously, the definition is not clear what is part, but we do know, everyone knows what is point. But in order to define it, we may have to be more clear. Okay, so in geometry, we take a point, a line, a plane, Euclid's word or plane surface as undefined. And the only thing that we can represent them intuitively or explain them with the help of physical model. Okay, so we can't just define it. One thing is clear, we can just make it understandable by the physical models. I hope Euclid's definition is clear to you. We would stop here, and from the next part, we will be starting with Euclid's axioms and postulates. Okay, so I hope that's not going boring and you're not feeling bored. I hope you're understanding the concepts. Thank you so much for attending today's lecture.